morning students. Today's topic is volume of the solid revolving about x-axis and y-axis. First draw y-axis x, O, x dash, y, O, y dash. From the origin to A is a line segment. O is a line segment on the first quadrant of the coordinate axis x and y. Now fix O. O is a line segment. O is fixed, rotating about x-axis. The line OA, OA rotating about x-axis. We get cone. The cone is rotating about x-axis. Now we want to find revolving about x-axis volume of the cone. Revolving about x-axis volume of the cone. This is a cone. Find volume of the cone. Volume of the cone is equal to 0 origin to some point A comma 0 is the edge point. Then 0 to A pi y square dx. The line rotating about x-axis, we get a cone. We get a cone. The volume of the cone is pi y square dx. Rotating about x-axis, then pi y square dx. Draw another x o x dash, y o y dash. Draw OA is a line segment. The line segment O is fixed. O is fixed. Now OA line segment rotating about y-axis. What will happen? This is a cone shape. How to find the area volume of the cone? In this case, rotating about y-axis. Therefore, volume of the cone is the line OA rotating about y-axis. We get another cone. Volume of the cone is zero to some edge point is A, 0 to A or B, in this case B. So 0 to B, pi x square dy, y rotating about y-axis, therefore dy, pi x square dy. In this case variable is y. Okay. Now these two are the two types of volume of the solid revolving about x-axis and y-axis. Rotating about x-axis, we get 0 A to B or 0 to A pi y square dx. Rotating about y-axis, then volume of the cone is pi x square dy. Now we are going to take EX number 9.9. Sum number 1. 1. 1 The volume of the solid, generated by revolving about the x-axis, rotating about the x-axis, the same meaning, revolving about the x-axis, underline x-axis. The region enclosed by 2x square, y is equal to 0 and x is equal to 1. Let y is equal to 2x square is a equation of the curve. Volume is equal to a to b y square dx. How to select this formula? Rotating about y square dx. Now y is a constant number. Outside the integral y square dx, limit vary from a to b. In this case 0 to 1. Substitute y is equal to 0, then x is equal to 0, x equal to 1. Substitute y is equal to 0, then this will imply x is equal to 0. Already x is equal to 1. Therefore the limit vary from 0 to 1. y square y 0 to 1, y is 2x square whole square into dx is equal to 4 pi. 2 square is 4 pi, 0 to 1, x power 4 dx. Next line, 4 pi into integral x power 4 dx is x power 5 divided by 5. Taken over limit 0 to 1. Next line, 4 pi, apply upper limit 1 by 5 minus 0. Therefore 4 pi divided by 5 cubic units. Why? Volume is given. That volume is wanted. Therefore cubic units. Hence the volume of the region is 4 pi divided by 5 into cubic units. Question number 2. Find the integration the volume of the solid, generated by revolving about x-axis. Underline the word x-axis. The region enclosed by y is equal to e to the power of minus 2x, y is equal to 0, x is equal to 0 and x is equal to 1. Y is equal to a to the power of minus 2x, a to the power of minus 2. Volume revolving about which axis? X-axis. Therefore volume of the solid is equal to pi y square dx taken over the limit x is equal to 0 and x is equal to 1. X is equal to 0, x is equal to 1. So the limit is, lower limit is 0, upper limit is 1. equal to pi is a constant number outside the integral 0 to 1. Pi square is a to the power of minus 2x whole square into dx is equal to pi e to the power of minus 2x whole square means e to the power of 2x into e to the power of 2x, but in this case e to the power of 4x, e to the power of minus 4x, e to the power of 2x into e to the power of 2x, adding the power e to the power of minus 4x into dx is equal to pi, integrating we have e to the power of minus 4x divided by the coefficient of x term minus 4a, taken over the limit 0 to 1. Now pi minus pi divided by 4 is a constant number outside the integral e to the power of minus 4x, taken over the limit 0 to 1. Now apply upper limit, we have minus pi by 4 of e to the power of minus 4 into 1 is minus 4 minus e to the power of 0. E to the power of 0 is 1. Therefore, minus pi divided by 4 into e to the power of minus 4, e to the power of 0 is 1. So, positive 1 is equal to minus pi e to the power of minus 4 divided by 4 minus of minus positive plus 1 into pi by 4 is pi by 4. Now, positive pi minus pi e to the power of minus 4 divided by 4, common pi by 4, pi divided by 4 is common number, therefore 1 minus e to the power of minus 4 is volume of the solid, hence volume of the solid is equal to pi by 4 into 1 minus e to the power of minus 4 cubic units. Cubic units. Now the integration, question number 3, find the integration the volume of the solid, generated by revolving about y axis, the region enclosed by x square is equal to 1 plus y and y is equal to positive 3. Y is equal to 3 is a straight line. X square is equal to 1 plus y is a curve. Let the equation of the curve be x square is equal to 1 plus y. This means y is equal to x square minus 1. X square minus 1. Now, table x, y, x equal to 0, apply y is equal to minus 1. X is equal to 1, apply 1 square is 1, 1 minus 1 is 0. Apply x is equal to minus 1, minus 1 whole square is positive 1, positive 1 minus 1 is 0. Next, we know that y is equal to 3 is a straight line passing through 0, 3 or 3, 0, 3, 0. Okay. Now draw a diagram. We have to take the table 0, minus 1, 0, minus 1. Next 1 0. 1 0. Next minus 1 0 on the left hand side of x-axis. Okay. Now y is equal to 3. Y is equal to 3. 1 2 3. Parallel to which axis? Parallel to x-axis. Y is equal to k means parallel to x-axis. X is equal to k means parallel to y-axis. Okay. Now this is y is equal to 3. The point is 0, 3. 0, 3. Okay. This is a straight line y is equal to 3. Now the diagram is okay. This is a diagram. This curve is rotating about which axis? Y axis. Rotating about a y axis. Therefore, the solid generated by revolving about y axis given. So, rotating about a y axis, the region enclosed by this. So, the formula is rotating about y axis, volume of the solid, volume of the solid is equal to pi x square dy, rotating about y axis. Therefore, pi x square dy. The limit vary from 1 to plus 1. So, minus 1 to plus 1. Pi is a constant number outside the integral. Minus 1 to 1 x square integral. Minus 1 to 1 x square is 1 plus y into dy pi is equal to pi dy. Integrating we get y plus y square divided by 2. Minus 1 to plus 1 is equal to pi, apply 1 plus 1 by 2 minus apply lower limit minus 1 plus 1 by 2 is equal to pi 3 by 2 minus 1 by 2 minus 1 is minus 1 by 2 is equal to pi 3 by 2 minus of minus positive 1 by 2 is equal to is equal to 4 by 2 pi into 4 divided by 2 is equal to 2 pi. Y axis limit is minus 1 to positive 3. Minus 1 to positive 3. Here minus 1 to positive 3. Now apply positive 3. 9 square by 2. Sorry, 3 square by 2 is 9 by 2. Apply lower limit, we get this. Next 6, 15 by 2. 15 by 2. Okay. 15 divided by 2. So 15 plus 1 is 16. Pi into 15 plus 1 by 2 is equal to pi 16 by 2 is equal to 8 pi cubic units. Hence volume of the region. Hence volume of the region is 8 pi cubic units. Next, question number 4. The region enclosed between the graph of y is equal to x square. Y is equal to x square is denoted by R. Is denoted by capital R. R means real number system. Find the volume. Find the volume generated when R is rotated through rotated through 360 degree about x-axis. So the rotating about a x-axis. Y is equal to x square. Let y is equal to x square. Table x y -1 0 1. Apply x is equal to 0, y is equal to 0. Apply x is equal to 1, y is equal to 1. Apply x is equal to -1 whole square is positive 1. The table is 4. Now problem is the region enclosed between the graph of y is equal to x square and the straight line graph of y is equal to x and the curve. Okay, y is equal to x square, then table is this. Let the equation of the straight line. Let the straight line be y is equal to x. Table is x, y. Now 0, -1, positive. Apply 0, 0. Apply 1, 1. Apply x is equal to -1, -1. Okay. Now draw the curve. This is y is equal to x straight line. Take the curve table 0, 0. Next -1, 1. -1, positive. Next 1, 1. 1, 1. The curve is passing through 0. between the straight line and the curve is of the position this one. So now volume of the region, the shaded region, rotating about which axis? X-axis is given, therefore volume x dash, y dash, next the curve is y is equal to x square. Now volume of the region, of the shaded region, is equal to 0 to 1 is limit, 0 to 1 is limit by y square dx. But in this case straight line below the curve, therefore first straight line is equal to 0 to 1. Pi is a constant number. Y means y1 square minus y2 square into dx. But y1 is straight line below the area. Straight line y is equal to x below the area. ST line. Y2 is curve. Now pi 0 to 1 y1 is y is equal to x, therefore y1 is x square minus y2 square x2 square x square whole square into dx is equal to limit vary from 0 to 1 x square minus x power 4 into dx is equal to pi integrating x square dx, we have x power 3 divided by 3 minus x power 5 divided by 5 taken over the limit 0 to 1 is equal to pi apply upper limit 1 by 3 minus 1 by 5 apply lower limit minus 0 is equal to pi into 2 5 minus 3 divided by 15 is equal to 2 pi divided by 15 cubic units. Next, question number 5. Find the integration the volume of the container, which is 1 meter, which is in the shape of a right circular conical piston. Right circular conical piston as shown in the figure. Now we have to take, this is a cross section. This is top radius, this is bottom radius. Okay. Now take x and y coordinate. Y dash, the cross section is, this is the form. Here A, here B, lower limit, upper limit. This is small radius, this is capital radius. This is a straight line, y is equal to cross section, therefore y is equal to x of the form. Okay. Minus A. B is, this case 4. A is 2. Therefore 2. Is equal to, rotating about which axis? Y axis. Therefore phi integral A to B x square dx. No, x square dy. By y square dx, rotating about x axis. Therefore phi y square dx. Phi y is equal to x, since y is equal to x is given. Therefore integral A to B x square dx. Now phi, the limit is in this case A to B. So integrating we have x power 3 divided by 3 taken over the limit A to B. Phi by 3 B cube minus A cube. B cube minus A cube. B cube minus A cube means we know that B minus A into B square plus BA plus A square. Right? Taken over the limit A to B. So equal to pi by 3 B minus A into B square plus BA plus A square. This is H. Therefore pi by 3 H. This is R, capital R, A is smaller. Therefore capital R square plus R into small r plus small r square from the diagram. Now H is equal to 2, since H is equal to radius. Small radius is 1, big radius is 2. Volume is equal to pi by 3 2 bracket 2 square is 4. Next BA 1 into 2 or 2 into 1 is 2 plus 1 is equal to 2 pi by 3 into 7 is equal to 14 pi divided by 3 cubic units. Hence the volume of the solid is equal to 14 pi divided by 3 cubic units. The watermelon has an elliptical shape. Has an elliptical shape which can be obtained by revolving an ellipse with a major axis. The major axis 20 centimeter and the minor axis 10 centimeter about the major axis. About the major axis means x axis. About the major axis means x axis. Find the volume using the integration. Find the volume using the integration. Given major axis. Major axis means 2a. C equal to 20 is given. A is equal to 10. Next, minor axis. Minor axis 2b. C equal to 10 is given. B is equal to 5. Equation of the ellipse, we know that major axis along x axis, then the equation of the ellipse is x square by a square plus y square by b square is equal to one of the form. In this case, a is greater than b. Major axis along x axis. So a is greater than b. Here a is 10, b is 5. Therefore x square divided by 100 plus y square divided by 25 is equal to 1. Next, y square divided by 25. Now in this case we want to find y square. Therefore y square divided by 25 is equal to 1 minus x square divided by 100. Taking LCM, we have 100 minus x square divided by 100. Now y square is equal to 25 into 100 minus x square divided by 100. These two are cancelled. We get 100 minus x square divided by 4. Y square is equal to 1 by 4. 100 minus x square. This is 10. Here minus 10. Here 5. Now rotating about which axis? X axis. Therefore this is half of the part of volume. Next, this side half of the part. Therefore volume is equal to volume of the ellipse. Volume is equal to 2 pi 2 into pi y square rotating about which axis? X dash y dash. Therefore pi y square dx. Now 2 into integral 0 to 10 middle to this side, 0 to 10 twice means half portion this side, left hand side half portion right hand side. So volume totally twice into pi y square dx. Now pi is a constant number, y square is 1 by 4 100 minus x square into dx. Now taking 1 by 4 is a constant number outside the integral, we get 2 pi divided by 4 integral 0 to 10 100 minus x square into dx. Now pi by 2 integrating, we get 100x minus x power 3 divided by 3 0 to 10 is equal to pi by 2 100 into 10 minus 1000 divided by 3 minus apply lower limit 0 is equal to pi by 2 1000 minus 1000 by 3, taking LCM we have pi by 2 3000 minus 1000 divided by 3 is equal to pi by 2 2000 divided by 3, pi by 2 into 2000 means 2 into 1000 divided by 3, cancelling these two we have 1000 pi divided by 3, here volume, therefore volume is equal to cubic units, volume V is equal to 1000 pi divided by 3 cubic units. Next, today homework number 1, find the volume of the solid. Find the volume of the solid that the results when the ellipse x square by a square plus y square by b square is equal to 1, a is greater than b is greater than 0. This means a is positive and also b is positive, is revolved about a minor axis, is revolved about a minor axis. The last problem, sum number 6, revolving about a major axis, so x axis. In this case, revolved about a minor axis, therefore y axis. You have to take y axis as a minor axis. Okay. Question number 2. Find the volume of the solid. Find the volume of the solid generator when the region enclosed by, when the enclosed by y is equal to root x, which is a straight line. Come on, y is equal to 2. And x is equal to 0 is revolved about the y-axis. These are the homework problems. Study well. Any doubt, reply the message. Thank you, students.